We're going to do a quick review of the information that you read last week in Module 9. As I mentioned last week, the first half of the book introduced you to the physical world around you. We studied air, we studied water, we studied the structure of the earth. And the second semester, we're getting into physics and chemistry and other physical sciences that don't involve life. In your reading this past week, you read that the most important concept in all of physics is that motion is relative. Remember that Dr. Weil discussed the fact that while an object might seem like it is motionless to you as you're looking at it from across the room, if someone was passing by in a car or someone was passing by in an airplane, they might see the object moving from their position. So let's see if we can go ahead and work with this concept. I'm going to go ahead and put up a sample problem on the screen, and we're going to read it and see if we can answer the questions. So it says, two boys are sitting together on a ski lift. As they sit on the lift chair, they watch their younger sisters head down the bunny trail. And so 3 questions are there. Relative to whom is the first boy in motion? Relative to whom is the first boy not in motion? And relative to whom are the sisters in motion? So the first boy would be in motion to the girls that are on the bunny trail. If they looked up at the boys, they would see them switching location as they go up in the chairlift. Meanwhile, the first boy is sitting motionless on the chairlift next to the second boy, and so relative to the second boy, the first boy is not going to be in motion. And finally, the 2 sisters on the bunny trail, they are going to be in motion relative to the boys who are looking down at them. As part of our discussion of motion, of course, we also discussed this past week speed. And one of the things that I wanted you to begin memorizing is the formula for speed. And so you were supposed to write it in on your homework sheet this past week. So speed is the distance that an object travels divided by the time it took to travel. And I like to tell my students that one way that you can remember, if you can't remember if distance goes on the top in the fraction or if time goes on the top, just remember miles per hour. Because if you'll remember miles per hour, you'll know that miles is a distance figure and an hour is a time figure. And so distance is being divided by time in order to figure out what the speed is. If you would like to shorten what you need to memorize, you can also write in S equals D divided by T, where S stands for speed, D stands for distance, and T stands for time. I thought that we would do a few problems together. We would have done this in class had we gotten together this past week, but since we didn't, we're going to go ahead and do it as part of the video. So number 1 says, Caleb roller skates 4.7 kilometers in 30 minutes. What is his average speed in kilometers per hour? So kilometers per hour is a distance divided by a time, and so we know that speed is distance divided by time. So we're going to go ahead and write in that formula, and then we're going to plug in the numbers. So the distance is 4.7 kilometers, and he was able to travel that in 30 minutes. But the question asks us to give the answer in kilometers per hour, so we're going to have to convert 30 minutes to half an hour, and we'll go ahead and do that as a decimal fraction, and we'll write in 0.5 hours. So in terms of, I've talked to you guys before about showing your work. For this module, showing your work involves writing the speed formula, speed equals distance divided by time, filling in the numbers, and then you may use your calculator. You don't have to manually do any division for me, and then you write the answer. So I've gone ahead and I've used my calculator to divide 4.7 kilometers by 0.5 hours, and the answer is 9.5 kilometers per hour. We'll try another one. Mary drives her car 435 kilometers in 4 hours and 15 minutes. What is her average speed in kilometers per hour? So again, we're going to show our work. We're going to write the speed formula. Speed equals distance divided by time. Then we will fill in the information we've been given. 435 kilometers is the distance. And the time is going to be 4 hours and 15 minutes. 15 minutes is 1/4 or 1/4 of an hour, and we show that as a decimal fraction by saying 0.25. Think of quarters. Quarters are 25 cents. Remember that a whole dollar is 100 cents. So we are going to go ahead and do the division on a calculator, and I get for the answer 102 kilometers per hour. Number 3, a van moves at 73 kilometers in 1 hour and 30 minutes. What is the average speed in kilometers per hour? Once again, we're going to write in our speed formula. Speed equals distance divided by time. And we'll plug in our numbers. 73 kilometers divided by 1.5 hours. We'll do our calculation or our division on the calculator. 73 kilometers divided by 1.5 hours, and the answer is 48.67 kilometers per hour. And of course, I went ahead and I rounded up for that answer. And finally, an airplane flies 245 kilometers in 3 hours and 15 minutes. What is the average speed in kilometers per hour? Write our speed formula. Speed equals distance divided by time. We'll plug in our numbers. 254 kilometers per hour divided by 3.25 hours. And we'll use a calculator to get the answer, which is 75.38 kilometers per hour. So, what if we have memorized the speed formula, speed equals distance divided by time, and instead of giving us the distance and the time, Dr. Weil gives us the speed and the time. How can we find out what the distance a vehicle or a person or a snail has traveled? So this is where algebra becomes very helpful. And so I'm going to practice with you how to manipulate a formula using algebra so that you can figure out any part of the formula. So in this case, we know that in algebra we can multiply something by its reciprocal in order to cancel out the number or the figure or the letter on the bottom. So in this case, we would be multiplying distance divided by time by the reciprocal of time. And so we're going to put time on the top, and we're going to put it over a 1. And we're going to multiply that on one side of the equation. And whatever we multiply on one side of the equation in algebra, we have to multiply on the other side. Remember, algebra is all about keeping things balanced. So we're going to go ahead and cancel out time. And so we end up with distance equals time times the speed. So let's see if that actually works. Does that actually work in a problem? So here's a problem. A police car drives with a constant speed of 64 miles per hour. How far can it travel in half an hour? So speed equals distance divided by time. We're going to plug in the numbers we've been given. We have 64 miles per hour. We don't know what the distance is, but we do know that the time is half an hour. So if we multiply each side by 5 hours, what do we get? Let's see. We're going to cancel out the 5 on one side of the equation, and so we're going to be left with that distance equals 5 times 64. And so we end up with 32 miles for the distance. Again, I've shown my work. I did my calculation on my calculator. Please remember to bring your calculator to class next week, by the way. All right, what if instead of giving us the time and the speed and expecting us to find out what the distance is, Dr. Weil instead gives us the distance and the speed, and he wants us to figure out the time? How would we go about doing that? So once again, we're going to turn to algebra, and we're going to manipulate the problem and balance it out so that time is left on one side of the equation and distance and speed are left on the other side of the equation. So we're going to do that by dividing one side by speed and dividing the other side by speed. We'll go ahead and cancel out speed, and we're left with time equals distance divided by speed. So let's see if that works in a problem. And here is a problem. An airplane flies with a constant speed of 840 kilometers per hour. How long, what time, will it take to travel a distance of 840 kilometers? So we'll go ahead and write down time equals distance divided by speed. We'll fill in the information, and we're left with a problem where we are dividing 840 kilometers by 840 kilometers per hour, and we should end up with a time for that. So when I do that either in my head, because it's an easy one, or if I do it on a calculator, I end up with it taking me 1 hour, or rather taking the airplane 1 hour. So we're going to go back over this next week when we're together, but for today I just wanted to show you how you can use algebra and not have to memorize 3 different formulas, one to figure out the time, one to figure out the distance, one to figure out the speed. If you can remember miles per hour, that speed is a distance divided by a time quantity, then you can figure out any part of that equation just by using algebra and moving the equation around. All right, this past week you also read about the relative speed of objects. And so you were supposed to fill in that when objects travel in the same direction, the relative speed is the difference between their individual speeds. Meanwhile, when they travel in opposite directions, the relative speed is the sum of their individual speeds. So, keeping in mind that difference means in math that you are supposed to subtract. So if 2 objects are traveling in the same direction and you are trying to calculate their individual speeds, you are going to subtract their speeds from each other. Meanwhile, in math, the sum means that you are adding. And so if 2 objects are traveling in opposite directions, you're going to add their speeds together in order to get their relative speeds. So let's go ahead and do some problems where we can practice that. And here is a problem. A car is traveling at 65 miles per hour north. A truck is a mile south of the car traveling at 70 miles per hour north. what is their relative speed. So with these problems, it really helps, and I encourage all of my students to draw it out. Otherwise, you're liable to make a very stupid error. Either you will think that they're headed in the same direction, or you will get it mixed up and have them headed in opposite directions when they should be traveling in the same direction. So I'm going to go ahead and draw it. Here is the car. Not very good, but still, there it is. It's headed north. And here is the truck, and it is also headed north, but it's about a mile south of the car. So it is coming up behind the car. So what is their relative speed? They are headed in the same direction, and we have learned that if they are headed in the same direction, their relative speed is the difference between their individual speeds. In other words, we are subtracting. So we are going to subtract 65 miles per hour from 70 miles per hour, and we end up with an answer of 5 miles per hour. But remember that when we're talking about the relative speed, we need to go ahead and say how they are related to one another. And so in order to have the answer be correct, we need to say 5 miles per hour toward each other. In other words, the 70 mile per hour truck is gaining speed on the 65 mile per hour car, so they are headed toward each other at about 5 miles per hour. Let's go ahead and do another one. We'll turn them around this time. This time it says a car is traveling at 65 miles per hour north, and a truck is a mile south of the car traveling at 70 miles per hour south. What is their relative speed? So again, we're going to draw it out. Here is the car headed north. Here is the truck headed in the opposite direction, headed south. So this time we know when things are traveling in opposite directions, their relative speed is the sum of their speeds. So this time we're going to add them together. So we have 70 miles per hour plus 65 miles per hour, and the answer is 135 miles per hour. And because we're talking about their relative speed, we need to say in relation to them in order to have a correct answer. So they are traveling at 135 miles per hour away from each other. So, in addition to a link to this short review video, I also sent you a copy of our quiz for this week. I'd like you to go ahead and do that as an open book, so good luck on that. One thing that I do want to mention before you start taking the quiz, because I haven't discussed it yet, is the difference between a vector quantity and a scalar quantity, and the difference between speed and velocity. Speed and velocity is probably easier to start with, and so I just wanted to remind you that when we are measuring the speed, we are measuring how fast something is going. And when we are measuring the velocity, we are measuring how fast something is going in a certain direction. That's a very, very important distinction that we need to keep in mind. So velocity is basically speed with directional information added to it. Keep in mind that distance doesn't tell you how fast something is going, it only tells you how long something is. Now, difference between scalar and vector quantity. Remember that a scalar quantity gives you information without telling you anything about its direction. So, for example, speed would be a scalar quantity because I'm not telling you what direction. A car could be traveling at 65 miles per hour. That is its speed, and we can measure that on a scale, but it has nothing to do with the direction that the car is moving in. Meanwhile, if we want to know something's velocity and we add the information about the direction it's headed in, then we have a vector quantity. So as you look at A, B, C, and D there, I can see that we have several scalar quantities there, and we have at least one vector quantity there. And hopefully, since it's an open book test, you'll be able to review the information from your text and figure out which is which. And so I'm going to go ahead and finish there for today. I do want to mention that we are going to, when we get back together after our snow day, when we get back together next week, we will go ahead and do experiment 9.1 together. And I think that I am asking you to go ahead and do experiment 9.3 on your own, and I think I give you a form to fill out with the for the information that you need to record doing that experiment. So good luck on that experiment. Looking forward to seeing you all next week. If you have any questions, please feel free to email me or have your mom text me this next week, and we'll go ahead and get off for now.